Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 30, Inverse Trigonometric Functions. A sine takes an angle and returns a ratio. An inverse sine runs that backwards. It takes the ratio and asks, which angle produced it? But sine repeats forever, so the answer would be endless. The fix is to restrict the domain to a single, agreed branch, giving one clean principal value. Master the domain and range of each inverse. That is where every mark hides, and the elegant identities, like sine inverse plus cosine inverse equals pi by 2, follow almost for free. Today, the principal branches, the graphs, and the key identities. One idea at a time. Here is what you will master today. First, the inverse trigonometric functions. Second, the principal value branches, the domain and range of each. Third, the graphs. Fourth, the key identities. And fifth, the addition formulas. One idea at a time. Let us set the foundation. The inverse. It answers a single question. Which angle has this sine? Why? Restrict. Sine repeats itself, so we restrict its domain to make it 1, 1, and only then can we invert it. The principal value. Each inverse has one agreed branch of answers. Its principal value. Master line. Know the domain and range of each, and all the identities follow. Now look at the picture. The graph of sine inverse x. The idea. The inverse trig functions, undo sine, cosine, and tangent. The restricted domain. Sine is not 1, 1, so we restrict it to build an inverse. The principal branch. Sine inverse has domain from -1 to 1 and range from -pi by 2 to pi by 2. The graph. It is the reflection of the restricted sine across the line equals x. Now the domains and ranges. Commit these to memory. Sine inverse and cosine inverse. Both have domain -1 to 1. The range of sine inverse is -pi by 2 to pi by 2. The range of cosine inverse is 0 to pi. Tangent inverse and cotangent inverse. Both have domain all real numbers. The range of tangent inverse is the open interval -pi by 2 to pi by 2 of cotangent inverse 0 to pi. Secant inverse and cosecant inverse. Their domain is the values with absolute value at least 1, that is, outside -1 to 1. Remember, the range of each inverse is its principal value branch. Now the identities that earn marks. The complementary one, sine inverse x plus cosine inverse x equals pi by 2. And likewise, tangent inverse plus cotangent inverse equals pi by 2, and secant inverse plus cosecant inverse equals pi by 2. Negatives. Sine inverse of -x equals minus sine inverse x. It is an odd function, but cosine inverse of -x equals pi minus cosine inverse x. Reciprocal. Sine inverse of 1 over x equals cosecant inverse x for suitable x. Self-inverse. Sine of sine inverse x is always x, but sine inverse of sine theta equals theta only when theta lies in the principal range. Now, look at the picture. The complementary identity. The two curves, arcsine increases while arccosine decreases. The identity, sine inverse x plus cosine inverse x equals pi by 2 for every x from -1 to 1. The same pattern, tangent inverse x plus cotangent inverse x equals pi by 2, and secant inverse x plus cosecant inverse x equals pi by 2. The ranges. Arcsine runs from -pi by 2 to pi by 2. Arccosine runs from 0 to pi. Now the addition formulas. Powerful but handle with care. The tangent inverse sum. Tangent inverse x plus tangent inverse y equals tangent inverse of x plus y over 1 minus xy, when the product xy is less than 1. The correction. If xy is greater than 1, add or subtract pi to land in the right branch. The sine inverse sum. Sine inverse x plus sine inverse I equals sine inverse of x root 1 minus y squared plus y root 1 minus x squared. The double angle. Twice tangent inverse x equals tangent inverse of 2x over 1 minus x squared, which equals sine inverse of 2x over 1 plus x squared. Careful, These hold only in the right ranges. Always check before you apply them. Now, the three graphs at a glance. Arc sine, increasing from minus pi by 2 up to pi by 2 on the domain minus 1 to 1. Arccosine, decreasing from pi down to 0 on the domain minus 1 to 1. Arctangent, increasing with horizontal asymptotes at minus pi by 2 and pi by 2. Now match each description to its function. Domain minus 1 to 1, range minus pi by 2 to pi by 2 goes to sine inverse. Domain minus 1 to 1, range 0 to pi goes to cosine inverse. Domain all real numbers. Arrange the open minus pi by 2 to pi by 2 goes to tangent inverse. And sine inverse x plus cosine inverse x goes to pi by 2. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Sine inverse x plus cosine inverse x equals pi by 2. Correct. Statement 2. The range of cosine inverse is minus pi by 2 to pi by 2. Wrong. It is 0 to pi. Statement 3. Tangent inverse has domain all real numbers. Correct. So, the answer 2 are correct. Statements 1 and 3. The trap is the range of cosine inverse in statement 2. Now, the 2 mistakes that quietly cost marks. The truth, sine inverse has range minus pi by 2 to pi by 2. Cosine inverse has range 0 to pi. The trap, giving cosine inverse the same range as sine inverse. The second truth, sine inverse of sine theta equals theta only when theta is in the principal range. The second trap, assuming sine inverse of sine theta equals theta for every theta. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The range of sine inverse. Minus pi by 2 to pi by 2. Question 2. The range of cosine inverse. 0 to pi. Question 3. Sine inverse x plus cosine inverse x pi by 2. Question 4. The domain of tangent inverse. All real numbers. And question 5. Is sine inverse an odd function? Yes. Let us gather it all in one breath. Inverse trig under sine, cosine, and tangent on a restricted domain. Sine inverse maps minus 1 to 1 into minus pi by 2 to pi by 2. Cosine inverse maps minus 1 to 1 into 0 to pi. Sine inverse x plus cosine inverse x equals pi by 2. And the same for tangent, cotangent, and secant, cosecant. Arcsine increases, arccosine decreases. Sine inverse of sine theta equals theta only in the principal range. Next class. Limits and continuity. The foundation of calculus. Back to the angle. Inverse trigonometry is simply trigonometry run in reverse, from a ratio back to an angle. The one subtlety is that sine and its cousins repeat, so we agree on a single principal branch and stick to it. Hold the domain and range of each inverse firmly in mind, and the beautiful identities fall out on their own. Sine inverse plus cosine inverse is always pi by 2. Arcsine climbs while arccosine falls, and a self-inverse only cancels inside its own range. Keep the branches straight, and this chapter becomes clean, reliable marks. Next class. Limits and continuity. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.